All right, let's take a look at another problem here. Let's do 2-23. So this is one that uses the ternary diagram. So we're looking to try to find the liquid and gas fractions of a mixture, and the mixture is, let's see, we got whatever 10 pound moles of a mixture that is methane's 55 mole percent, propane is 20 mole percent, and N-pentane is 25 mole percent. These should add up to 100 because it's all of the components of the mixture. So we need to go find the diagram, and this is, oh, there's other important information there too. T is 160 Fahrenheit. P is 1500 psi. So remember when we were talking about these tertiary diagrams, there's a diagram for every temperature and pressure. So we would need to go find that. If you go up in the book, you'll find the figure. The figure looks like this guy, actually. Let me get myself out of the way here a little bit. So I can make this plenty big. So here's the diagram, and you'll notice there's some key things. It is for this pressure, and it is for this temperature. It just happens to be for the problem that we're looking at. And here's our components: the methane, propane, and pentane. So we're trying to figure out how much liquid and gas fractions there are. So if you had a mixture that's over here, you know it's all liquid. It's over here, it's all gas. So we're looking probably under this dome. This is our vapor dome. And then here we have a couple of tie lines showing us the equilibrium lines. And here's our critical point. So anyway, to start off, we can go ahead and start measuring. So it was 55% of the methane. So we're looking for 55% of this guy. So that's a decimal actually, right? So up here at the top, if we're at the very top, that's 100% methane. So we're in increments of 5. So right here you'd be 20% methane on this line, 40 on this line, 60. So 50 is right in here. We're looking at 55% methane, so it's closer to this side. So here would be 60%. Right here is the 55 methane line. Now, propane, the question gives us propane is 20. So we're looking for 0.2 propane. Let me get this turned around here. I think that's good, yeah. So all the way here at the end, that's 100% propane. All the way on this end, this line is 0%. So right about here is 20% propane. So let's, not exactly straight there, that's a little straighter. Let's draw ourselves a line here. So there's the 20% propane line. Now, last but not least, the pentane. And the pentane line, so right here would be 100% pentane. Over on this side, 0%. And if we come in here, right in here is our 25. So there's the 20% pentane. These are 5% increments. So right about there would be our 25%. I'll go ahead and write that. 25% pentane. So the point we're looking at is right here. Let me change colors. I'll make it a dot. We're looking at this spot right here. So that's where our mixture lies. It's under the vapor dome. So we've got some mixture of liquid and gas. So if we're coming from this way, our liquid would hit here, or this bubble point line would be the starting point of when you get bubbles appearing. Dew point would be the last little bit of gas going, or liquid going away before you're all gas. So this tie line, let me make another line. You see that little dash line? That's the equilibrium line. That's where the actual, remember our liquid vapor tie lines are not really straight under the dome anymore because we've got a mixture. So let's see, I'll draw you a line here. So let's highlight that line right there. This is the line we're looking at. So on this line, our mixtures would be various amounts of liquid and gas. And the way that you measure that is by looking at the length, and you seriously measure it with a ruler. I'm not kidding here. So first thing we want to do, let me change it this, we want to measure kind of the different lengths of these lines. So let me get this over here lined up a little bit. So you're trying to measure basically these dimensions to be able to know what you're looking at. So the overall length is going to be on the denominator of what we're looking at. So I think this ruler is in centimeters. So here's one centimeter, 2 centimeters, 3 centimeters. This would be 35 millimeters, 36, 37. That looks like maybe 37 and a half. So this total, let me do this. This total length here is 37.5 millimeters that we just measure with this ruler. So it doesn't matter, you can measure in inches or feet or whatever makes sense, however big the chart is. So now let's measure this distance here, which would be 1, 2, looks like 21 and a half, 21.5 is that length. And then let's measure this one. Well, it's actually the difference. So it should be, looks like 15 and a half maybe. So, and we can do the math. I'll do 37 and a half minus 21 and a half equals 16. Okay, we'll say that. Just keep the numbers straight. So that distance is 16 right here. So the way we need to look at this is the liquid component is the length of this line. The liquid fraction would be the length of this line here divided by the total length. And the gas fraction would be the length of this line divided by the total length. So let me bring my thing back over here. So let's look at liquid fraction is going to equal to 21.5 divided by 37.5. And so do the math there. That is going to be 0.57. So this mixture is 57% liquid. Gas fraction is the opposite of that. So you could take 1 minus this if you want, but just for clarity, I'll write this 16 over 37.5. 16 over 37.5. That is 0.427. So this mixture is 42.7% gas. Now we want to get total moles. We had the 10, so you would just multiply that times this. So the liquid moles would equal to 10 pound moles times 0.573, which is going to equal to 5.73 pound moles. And the gas mole is 10 pound mole times 0.427, which is going to equal 4.27 pound mole. So there's your answers to that question. You know, you can see there's some other interesting things over here too. Like if my mixture landed, say, right here, that would be a, let's look, if I said it landed right there, that would be a mixture of, let's see if I can write that out. Right here would be a mixture that is here's 100% pentane. So this one would be in pentane. This one would be 55% pentane. It would be the propane amount. It would be, let's see, here's 100%, so 40, that's 40 right here, 30, so this would be 30% propane, and then our methane, it would have to add up, so that I got 85, so it should be 15. You turn it that way, here's 20, 15. So 15% methane. So this mixture, if you looked at it, it's outside the vapor dome. It would be all liquid at that point. So it'd be 10 pound moles of liquid. That makes sense. Likewise, if I had a value that was up here, let's say, actually let's show you one that's on this line right here. How about this guy right there? So at this point, you basically have 0 pentane. If you're looking at this point, we've got C5 equals 0, C3, NC5, C3, so you got the propane. It's not much propane, so here's 20, 15% propane, C1. This may be a natural gas. Methane, here's 100%, 5 or 100, 95, 90, 85. It's got to add up to 100, 85. So that's 100 if you add those up. So this would be basically all gas, and there's no pentane. So that's how you read these diagrams. So if you aren't under the vapor dome, you can't have liquid and gas both, and you don't need to bother with this. Technically, if you're out here, you're probably a supercritical fluid, but over here, definitely liquid, over here, definitely gas. Oh well, there's that problem.